Imagine trying to build a city, not just in some remote desert, but on a totally different world. That is the incredible challenge, and honestly, the amazing opportunity of settling Mars. So let's dive into how humanity's own cosmic construction crew is planning to build our future tens of millions of miles away from home. To really get a grip on this problem, let's just start with a number. This is roughly what it costs to launch 1 single kilogram, that's about the weight of a pineapple, to the moon. Now, imagine getting it all the way to Mars. Yeah, the cost becomes literally astronomical. So that begs the question, right? If shipping a single brick is going to cost you more than a mansion back on Earth, how in the world could you ever build an entire city? Well, the answer is kind of simple. You don't. You don't bring your construction materials with you. You see, the single biggest roadblock to building off-world is the mind-boggling cost of freight. Every single tool, every spare part, every building block has to fight its way out of Earth's gravity well. And that forces a completely radical shift in thinking. You have to move away from shipping and start thinking about self-sufficiency. And that shift leads us straight to the core solution, a philosophy with a fancy name, In-Situ Resource Utilization, or ISRU for short. It's actually a really simple and beautiful idea. To build on Mars, we have to learn to use what Mars itself already has. It's the ultimate version of living off the land. So here's the official breakdown. ISRU is all about harvesting and processing local materials, doesn't matter if it's moon dust or Martian air, to create everything we need right there on the spot. And look, this isn't just about saving money. It's the only way we can possibly set up a real long-term home beyond Earth. So what ingredients does Mars actually have for us? Well, for starters, its atmosphere is over 95% carbon dioxide, which is a fantastic source of both carbon and oxygen. The ground is covered in this dusty soil called regolith. There's tons of water ice at the poles and just under the surface, and you can even get nitrogen from the air for more complex chemistry. These are our raw materials. And get this, we can literally turn that thin Martian air into a high-tech building material. Using solar power, a special electrochemical process can grab CO2 right out of the atmosphere, split it apart, and give us 2 absolutely vital resources: breathable oxygen for us and incredibly strong, super lightweight carbon nanofibers for building things. Air is one thing, but the ground beneath our feet? That's a whole other resource. And this brings us to stage 1 of our construction plan, literally 3D printing with Martian dust. And this is the machine that could make it all happen. It's a prototype of a technology called Selective Separation sintering, or SSS. It's a new kind of 3D printing that's designed specifically to work with planetary soil, a key invention from Dr. Kosnies and his team. So how does this thing work? Well, SSS basically takes a powder, in this case fake Martian regolith, and uses heat to fuse the little particles together into a solid object. The result is this really tough, ceramic-like material, strong enough to create landing pads that can take the intense heat and force of a rocket coming down for a landing. And this just brilliantly illustrates the huge leap in thinking that ISRU makes possible. We're moving away from the slow, expensive, and frankly mistake-prone manual labor of the Apollo days, and we're heading towards a future where autonomous robots can just rapidly print entire structures, cutting costs and improving quality like crazy. Okay, but a Martian base needs a lot more than just bricks and landing pads, right? It needs metal tools, plastic parts for equipment, complex composites for structures. And that brings us to stage 2, creating an entire industrial forge, right there on Mars. This slide really breaks down the fundamental shift. You know, instead of building massive things on Earth and then trying to cram them into a tiny rocket, in-space manufacturing lets us ship raw materials or simple parts and then build what we need on site. We can weld, form, and assemble structures that are way bigger than anything that could ever fit inside a rocket. So, here's the crucial point. A Martian factory could have an incredibly diverse menu. Using local Martian resources, we could forge aerospace-grade metals, 3D print tough plastics like Lexan for greenhouses or ABS for tools, create advanced carbon composites for specialized parts, and maybe even print basic electronics, the whole shebang. All right, so we've covered printing with dust and forging metal, but now we get to the most incredible concept of them all, a building material that doesn't just get printed, it actually grows itself. This is stage 3. And this isn't just science fiction. As Dr. Congrui Grace Jyn, one of the brilliant researchers behind this idea, puts it, This tech could be a total game changer for long-term colonization. It's a huge step toward truly sustainable, autonomous construction. So what you're looking at here is a microscopic snapshot of this system in action. It's basically a synthetic community that works like lichen. You can see the red stuff, that's cyanobacteria. They act like tiny solar-powered food factories. And then the clear web-like stuff, that's fungal filaments. They're the construction crew, weaving everything together. Here's how this amazing partnership works. The cyanobacteria soak up the Martian sunlight and carbon dioxide to make nutrients. This becomes food for the fungi. The fungi then grow into this dense, web-like network that grabs all the loose Martian dust and binds it together into a solid, strong, concrete-like material. It literally builds itself. How cool is that? And this is where it all comes together, the ultimate vision. Researchers are working on a Regolith ink made from this living material. Autonomous 3D printers could then use this ink to construct entire habitats, growing the structures layer by layer, maybe even before the first humans ever set foot on the planet. So let's just take a step back and appreciate the incredible journey we've just been on. We've gone from being crushed by our dependence on Earth to seeing the real promise of a truly independent, self-sufficient frontier. You can see the roadmap taking shape, right? It's a clear, logical progression. We start by facing the problem of cost. That leads us to the ISRU solution of living off the land. From there, we build up our skills, first printing simple things from dust, then making advanced parts, and finally deploying these futuristic, self-growing materials. That's the path from a tiny outpost to a real city. And all of this leaves us with one final, huge question. This technology isn't just about Mars. It's about developing the ability to build, to create, and to thrive in any environment. So once we finally master the art of building anything, anywhere, what else becomes possible for us?